Okay, so these are the section 2.2 notes, and we're going to be looking at the graphs of functions. This is just going to go into some more detail on functions in general. We're going to be looking at how we can get a lot of information about a function just from the graph, and we're also going to look at how we can figure out some information about the function using the equation as well. We're covering all of 2.2 with one set of notes, and you'll have homework on all of 2.2. Some of it has historically caused struggles for students. It's something that it takes a little bit of practice, but I think that the more you practice it, the more confident you feel, the better off we'll all be. So make sure you're paying close attention, especially when we start kind of looking at the graph. So the first thing that we have with a function, not every collection of points in the xy plane represents the graph of a function. And for a function, every x has to have exactly one y in the range. So this means that I can't contain two y values for one x. If I'm looking at a function and I've got two y values for one x, then it's not a function. So what we have is, if I'm looking at the graph of a function, I can draw vertical lines. And as long as my vertical lines never cross 2 points, well, then I'm looking at a function. If my vertical line crosses 2 points, I'm no longer looking at a function because my y value has been repeated. And that's not okay. Every input has to have exactly one output. So the application of the vertical line test is pretty straightforward. You go through and you just start drawing some vertical lines. I can't really make these lines perfectly vertical. I can make them close, but we can see here, as I draw vertical lines, it never crosses. So this is a function. It passes the vertical line test. Over here, it gets a little bit more complicated. If we zoom in, we're only really doing the vertical line test where you think it might be failing. So I go through here, I draw my vertical lines. Again, I see that it really isn't passing 2 points at any point. This also passes the vertical line test. It's a function. All right. Now, over here, I've got two functions. I draw one vertical line. Would you look at that? I draw my vertical line. I've got a y value here and a y value there. That's no good. So this is not a function. It fails the vertical line test. Just like over here, this is not a function. It's going to fail the vertical line test because I pass two different y values for one x, so not a function. This is really straightforward. You guys have done this in Algebra 2. You've done it in Algebra 1. This is nothing that should be groundbreaking. We should be very, very confident in doing the vertical line test to determine whether or not something is a function. Now here's where it gets a little bit more complicated. Determining information from a graph. So right now I have a graph of a function. And in fact, the book chooses a function that they know you're not going to learn until chapter 6. This is the graph of 4 times the sine of theta. You don't know what that means right now, and that's okay. You don't need to know what it means right now. But what we can do is we can look at the graph and we can still figure out a lot of information from this graph. For part A, it's asking us what are f of 0, f of 3 pi over 2, and f of 3 pi. So f of 0, f of 3 pi over 2, and f of 3 pi. What this is asking us, this is saying when x is equal to 0, what's the y value? Again, you can look at this graph and you might not have any idea what the function of this graph is. But you can look at the graph and say, well, I know x is 0, and when x is 0, y is 4. So that means f of 0 must be equal to 4. Just like I can say to myself, I can see when x is 3 pi over 2. When x is 3 pi over 2, my y value is 0. So that means f of 3 pi over 2 is 0. F of 3 pi, again, I can see when my x is 3 pi. I can see what that makes my y value. So I say that that means f of 3 pi is negative 4. All right. That's kind of the easy one. You're just looking at your xy pairs and seeing how they match up. Next thing, what is the domain of f? Here, this one's a little bit tricky because I've got endpoints. And what I see, domain refers to my x values. This is my first value. I've got an endpoint. So that means that my domain starts at x, or is 0. My x is 0 where my domain starts. I've got another endpoint over here, and my x is equal to 4 pi. So my domain is between 0 and 4 pi. There's a few different ways I can write this. The most straightforward way is saying 0 to 4 pi and putting it in brackets because you have solid endpoints. I could also write 0 is less than or equal to x, which is less than or equal to 4 pi. I could also write out a sentence. The domain of my function is between 0 and 4 pi. All of those are acceptable. Now let's say that this function continued onward over and over, and we had arrows going in either direction. Well, then my domain would become all real numbers. But my domain is not all real numbers in this case. My domain in this case is only 0 to 4 pi because I have these solid endpoints. The next question is, what is the range of f? Figuring out the range is a little bit less straightforward because what I have to do here is I have to look and say to myself, all right, what is my lowest and highest y value? Domain's fairly easy because we read left to right. We're used to that. But for my range, what I have to do is I have to figure out what's my lowest y value. My lowest y value is going to occur where I have these little dips at the bottom. And I see that my lowest y value is -4. My highest y value occurs where these little peaks are happening. And that's happening at y is equal to +4. So that means the range of my function is from -4 to 4, or -4 is less than or equal to y, which is less than or equal to 4. I'm doing the exact same thing I did with my x to figure out what my domain or range is, but with y it's a little bit less straightforward. And x I'm looking from the left to the right. With my y's I have to look both vertically and I have to look vertically. I have to look at the top, I have to look at the bottom. I have to see where those lowest or highest values lie. I can't just look at the start and at the end. So that's how I go about figuring out my range. Listing the intercepts. So I'm going to do D over here to give myself some space. I've got a y-intercept at 0, 4. And a y-intercept is when x is 0. X-intercepts are where it crosses the x-axis. I've got 4 x-intercepts here. I've got 1, 2, 3, 4 x-intercepts. Everywhere where it crosses the x-axis is considered an x-intercept. My 4 x-intercepts are pi over 2, 0. I believe the next one is 3 pi over 2, 0. Yes, it is. 5 pi over 2, 0. And 7 pi over 2, 0. Again, all I'm doing here is I'm looking at my graph. I'm seeing the points where it crosses the x-axis. It's just looking. That's all I need to do. There's no heavy math here. It's just looking at the graph and knowing, okay, these are the points where my y is equal to 0. These are the points where it crosses the x-axis. Or in the case of my y-intercept, where it crosses the y-axis. So y-intercept is up here. How often does the line y equal 2 intersect the graph? Well, this one's kind of straightforward. I'm just gonna, that's a highlighter. I'm just gonna go ahead. I'm gonna make a line for y is equal to 2. This is a linear equation, which you guys know well. And I look and I just say, all right, how many times does this cross? 1, 2, 3, 4. Okay, cool. It intersects the function 4 times. I draw that line, y equals 2 across, and I see that I've got 4 intersection points. Awesome. For what value of x does f of x equal -4? All right, so this is telling me y is equal to -4. What are the x values that make y equals -4? So I go down, I look at my 2 points where y is equal to -4. I see my 2 points where y is equal to -4 are x is equal to pi and x is equal to 3 pi. So those are my two x values where y is equal to -4. That's simple, that's straightforward. And then finally, for what values of x is f of x greater than 0? So this is where I get a lot of students who struggle because we struggle with figuring out how to write things in terms of x. So what I have to do here for g is understand that I am talking about x values, and I'm only talking about x values. My graph is greater than 0 wherever it lies above the x-axis. So it's greater than 0 here, it's greater than 0 here, it's greater than 0 here, and it's greater than 0 there. I've got a few spots where it's greater than 0. I've got a few spots where it's less than 0, but we're only going to refer to this in terms of x. So I go through and I ask myself, all right, where does this graph start? This graph starts at 0, and 0 is an endpoint. It's a firm number, so I'm going to go ahead and I'm going to draw a bracket around it. Now that I've done that, I'm going to say, all right, it stays positive. It stays above 0. My y values are positive numbers until I get to pi over 2. Once I'm at pi over 2, it crosses the x-axis and it becomes a negative y value, and it stays a negative y value for a while. Now, this is just greater than. It is not greater than or equal to. Because it is not greater than or equal to, I use a parenthesis. If this were greater than or equal to, then I would go through and use a bracket as well. But again, it's not. It's just a greater than 0. However, this is not the only interval. These are not the only x values where my y value is greater than 0. Once I get back here to this 3 pi over 2, yet again, I'm greater than 0. So I put a union, which is just a u. I'm just talking about greater than, not greater than or equal to, so I'm going to use a parenthesis. And then I'm going to say, starting at the x value of 3 pi over 2, my y values become positive again. And my y values stay positive. All of these y's are positive, 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 positive until I'm here. And then I hit the x-axis again, and when I cross that x-axis, I get negative values. So I say, all right, that was positive until I got to 5 pi over 2. Once it got to 5 pi over 2, it crossed the x-axis again and became negative. And I'm going to use a parenthesis because it's not or equal to. I'm not trying to figure out what values are also 0, just values that give me greater than 0. And then finally I see, yet again, there's going to be another period where this x is greater than 0. And it starts being greater than 0 when x is equal to 7 pi over 2. So I put another union in, I put a 7 pi over 2. And then here I see, all right, my entire function stops at 4 pi. And when it stops at 4 pi, it doesn't go on. That's a solid endpoint. It definitely is greater than 0 there. I use a bracket. So this is the best way to represent it is by interval notation. I'm not going to use inequality notation here. I'm not going to use set builder notation here. Using interval notation when we're talking about from a graph is usually your best bet because you can read left to right, and representing your x values as you move left to right is going to help you the most. Now, this is something that students have struggled with, is reporting things via x values. Please, please, please ask me questions when you're confused. This is something that it takes some practice. You got to get used to looking at graphs in terms of x. However, everything we report is in terms of x. I realize there's a lot of little rules. If you're not perfect with your parentheses, I'm not going to take a ton of points off. If you're not perfect with your brackets, I'm not going to take a ton of points off. But what I do need to see is that we understand when we're talking about things happening to y, we still report them as x. X is an independent variable. Nothing changes the x values. The y values change in relation to x. So even though we're talking about y values, even though we're talking about something that happens to y's, we still report it in terms of x because that helps us. So I realized this slide had a ton of information. There were a ton of things going on. That's okay. We were able to work it all out. If you have any questions, again, please come ask me. Reading graphs, this has been something that is, students will think that they have it, and then we'll get to the quiz or a test, and it'll be a sudden struggle. This isn't something that needs to be a sudden struggle. Come talk to me sooner rather than later. Let's figure this out. Let's find out how we can read our graphs better. All right. When we go into part 2, so this used to be a 2-part lesson. Now I've just turned it all into one lesson. Part 1 is doing the vertical line test and figuring out everything from a graph. So this is all part 1 is. Part 2 is a lot more straightforward because we get back to kind of what you're used to doing throughout all of Algebra 1 and Algebra 2, which is working with equations. Some of you are still struggling with equations and we're perfecting them, and that's okay. That's why this class exists, is so that way we can really strengthen our algebra skills and make sure we know what we're doing before we enter calculus. So if we're still a little bit lost here and there, that's okay. We're going to pinpoint in now. All right, so we're asking, is the point 1/1/2 on the graph of f? Well, all right, all that's asking me is when x is 1, is y 1/2? That's the question. So the easiest way to figure that out is to figure out what the value f of 1 actually is. So I'm going to figure out 1 plus 1 over 1 plus 2, and that's equal to 2/3. So the point 1 2/3 is on the graph, and now I can definitively say that the answer to this is no. It's not on the graph. The point 1 2/3 is on the graph. So that's all that we had to do for that question. Pretty straightforward, easy stuff. All right, the next one. If x is equal to 2, what is f of x? What is the point on the graph? So this means that you plug 2 into your x. You say f of 2 is equal to 2 plus 1 over 2 plus 2, which is equal to 3 over 4. So that means f of 2 is equal to 3/4, and we have a point 2 3/4 on our graph. And that's all it is. You plug 2 in for your x value and figure out what your y value is. That's all that question's asking you to do. All right, if f of x is equal to 2, what is x? So this one's a little bit different. This is saying your y value is equal to 2, solve for x. And we gave you a little bit of a tougher equation. You've done these before in Algebra 2. However, it might have been a bit since you've done this. So I'm going to go ahead and I'm going to say 2 is equal to x plus 1 over x plus 2. I'm going to start solving. I'm going to multiply both sides by x plus 2. Just by x plus 2. Those are going to cross out. And I will get 2 times x plus 2 is equal to x plus 1. Now, I see that I've got some x's here. The only real thing that's going to help me solve for the x's is to distribute that. Because I could divide by 2, but then it's going to give me random x's in random spots. I'm going to end up with 2x plus 4 is equal to x plus 1. And now I'll solve. I'll subtract x on both sides. I'll subtract 4 on both sides. These x's cross out, those 4's cross out, and I'm left with x is equal to -3. So that's what my x value is. So when I know that f of x is equal to 2, or y is equal to 2, I've got an x of -3, and I've got a point -3, 2 on my graph. And that's all we need to do there. All right, our next one. And again, the book is going to give you a lot of problems like these where you're going to get a function. It's going to be like A through F, asking kind of general questions, just getting you to practice these basic mathematical skills. What are the x-intercepts of the graph, if any? What are the points on the graph of f? So an x-intercept is when y is equal to 0. So again, I'll do similar to what I did in C. I will set 0 equal to my entire function here. I'll put x plus 1 over x plus 2. I'll multiply this entire function by x plus 2 on both sides to cancel it out. And would you look at that, when I multiply x plus 2 on both sides, they go away. And I'm left with 0 is equal to x plus 1. And then x is equal to -1. You might be saying to me, Mr. Yehlen, that's really weird. How can I just get rid of the denominator like that? I don't think that that's okay. Well, remember, to figure out a fraction, for a fraction to be equal to 0, the only thing that matters is your numerator being equal to 0. I kind of did a superfluous step here. I went through and actually solved for the entire function. That's unnecessary. I could take the time to just set the numerator equal, because when you have a fraction, numerator equal to 0 means the entire thing is 0. Because 0 divided by anything is 0. But again, I could solve for the entire function. I could say, all right, I know my y value is 0. I'm going to set it equal to the entire function. I'm going to solve for that x value. And I find that it's -1. And that point on my graph would be -1, 0. All right. And again, we've already seen this. We're looking at it again. If f of x is equal to 3, what is the value of x? So y is equal to 3. What's x? I go through, I say 3 is equal to x plus 1 over x plus 2. We've done this before, x plus 2 on both sides. Those cross out. 3 times x plus 2 is equal to x plus 1. 3x plus 6 is equal to x plus 1. Subtract x, subtract 6 on both sides. Those cross out. 2x is equal to negative 5. And then x will be equal to negative 5 halves. So I've got a point, negative 5 halves, 3. So those are the two parts to answer that question. We've got a point, we've got an x value. Again, if you have a y value, you set that y value equal to the entire function and solve for x. Finally, we've got this function f of x. Well, not finally. We've got this function f of x. What is the domain of the function? I look here. I see that this is a rational function. This is f of x is equal to x plus 1 over x plus 2. As we learned in the 2.1 part 2 notes for the domain of a rational function, and we know that it's rational because I've got this variable x in my denominator. I set my denominator equal to 0. I solve and I get x is equal to negative 2. I can't have 0 in my denominator, so this means that my domain of this function is all values of x as long as x is not equal to negative 2. So this is practicing that skill that we already learned. We know that x is, we can't have an x that gives us a 0 in the denominator. Negative 2 would create a 0 in that denominator. Therefore, negative 2 can't be in our domain, and that's our only domain restriction. So it's all real numbers except for that x can't be equal to negative 2. Now finally, what is the y-intercept of the function? This one's really simple. Whenever you have the y-intercept, you set x equal to 0. So this is the exact same thing as saying, what is f of 0? You plug 0 into your function, 0 plus 1 over 0 plus 2. That's equal to 1/2. So your y-intercept is 0, 1/2. Whenever you're asked to find your y-intercept, you plug in 0 for x. That's something that we learned in Algebra 1, something that you've continued in Algebra 2. So this is a skill that whenever you see the words y-intercept, plug in 0. It's really easy, really straightforward. You've got a homework assignment. I'd start working on it while you're at home. See where you're struggling. Come into class with questions ready so that way you know what you're struggling with, you know what you have perfected. You can talk to me. You can figure things out. Please, please, please pay attention to the answer key versus your homework. Don't just answer them and think that you know it. Check your answer key, especially with the reading graphs, especially with these function skills. The stronger you are in this, the more confident you're going to be all year, because even though this is some pretty basic stuff in review of Algebra 2, we're going to get into this with all of the new functions we start learning in the second semester. And knowing how to do these skills well is going to be a huge saving grace in that second semester. So start working on the homework, ask me any questions you have, and have a great night.